Hello everyone. This class is a continuation of previous class. In previous class we discussed high pressure system of anesthesia machine. In this class we will be discussing intermediate pressure system of anesthesia machine. So intermediate pressure system has following components. We have pneumatic part of master switch. As we have discussed earlier, master switch has two components, electrical part and pneumatic part. So pneumatic part comes under intermediate pressure system. Then we have pipeline inlet connections. We have pipeline pressure gauges. We have oxygen pressure failure devices, which are a safety feature of anesthesia machine. There is presence of gas selector switch in newer machines. We have second stage pressure regulator to further decrease the pressure. We have oxygen flush in intermediate pressure system. We have flow adjustment control knobs in intermediate pressure system, and there may be presence of an alternative oxygen control in intermediate pressure system. So, we will be discussing these components one by one. This is a diagram of anesthesia machine. We have discussed it earlier. Just revisiting intermediate pressure system. This is intermediate pressure system. These are pipelines, oxygen, nitrous oxide, air. This is filter, followed by unidirectional check valve and pressure gauge. Then we have pressure relief valves for each pipeline, followed by specifications. So in oxygen there is a power outlet, there is a outlet for oxygen flush directly to the common gas outlet, and we have oxygen pressure failure devices, outlet for oxygen pressure failure devices up to other pipelines as well. We have master switch, as we have discussed, pneumatic component of master switch. Then we have one knob for for gases to vent out to the atmosphere. This outlet is used for Mapleson circuits. We can use for Bain circuit. And then we have, after oxygen pressure failure devices, we have secondary stage pressure regulators, followed by filters and flow control knobs for flow meters. So all this is discussed is in intermediate pressure system. Coming to master switch. Master switch, oxygen flush is independent of this switch. Then we have pipeline inlet connections. We generally use air, oxygen and nitrous oxide. They have a Schrader probe, and there are safety systems for connection. One is diameter index safety system, in which there is different diameter inlets for each gas. Then we have non-interchangeable screw threads. These are the safety features. Pipelines have unidirectional check valve to maintain flow in one direction only, and filter as a safety feature. After pipeline inlet connections, we have pipeline pressure gauges. Pipeline pressure gauges measure the pipeline pressures. We have to remember that the sensing point of pressure measurement is located on the pipeline side of the check valve. So the original from where the pipeline gases pressure is originating, that pressure will be sensed, not the pressure that is entering the machine. So pipeline side of the pressure is being sensed by pipeline pressure gauges. The measurement can be in gauge or digital, and we have to check pressures, and usually the pressures of intermediate pressure system are 50 to 55 psig. So after pipeline pressure gauge, we have oxygen pressure failure devices, very important devices. They are a very important safety feature. They prevent delivery of gas containing no oxygen to patient. They prevent they prevent delivery of hypoxic mixture to the patient. So the two functions of oxygen pressure failure devices is, one is it turns off other gases. Other gases includes nitrous oxide and air. It turns off other gases. Second function is it gives alarm when oxygen pressure falls. So, oxygen pressure failure devices, the function is if the mixture has no oxygen or less oxygen, it will prevent the delivery of mixture of gases. So, oxygen pressure failure devices are also known as oxygen failure safety valve or fail-safe devices. They are placed in the piping system of other gases. Other gases include nitrous oxide and air. They shut off the other gases, and the other thing is they can proportionately decrease the flow of other gases. Suppose oxygen and nitrous oxide are in combination, and suppose the flows are 4 liters and suddenly oxygen goes to 0. So, nitrous oxide will also fall to 0, and there can be proportional decrease. Suppose 4 to 2 liters or 1 liter is sudden decrease in oxygen flows, then nitrous oxide flow will also decrease proportionately. So, how to check oxygen pressure failure devices? We need to increase the flows of oxygen and the other gas. Other gas can be nitrous oxide or air. We have switched on the flows of both the gases, and we disconnect the source of oxygen. We disconnect the source of oxygen and then we observe the flow of other gas. There should be a decrease or shutdown of the other gas, and if this happens, then the oxygen pressure failure device is working, and then we can reconnect to again check the beginning of the flows of the other gas along with the oxygen. So, after checking, we are assured that patient will not get hypoxic mixture in case of there is sudden discontinuation of oxygen supply. So, we have oxygen supply failure alarms as well, which start within 5 seconds of shutdown of oxygen, and they can also sound when the oxygen pressure is less than 30 psig. So, we have to check oxygen pressure failure system, and we have to keep in mind that they do not offer total protection against hypoxic mixture. We have to keep this in mind that they do not offer total protection against, it is not 100% fail safe device. We have to just keep this in mind. We have to check this, but we have to remember that there can be errors as well. So, it senses pressure, not flows. This is a diagram showing oxygen. This is a schematic diagram showing oxygen pressure failure device. The gas in green is oxygen. It is also labeled as controlling gas, and the other gas is in blue, and it can be nitrous oxide or inhaled anesthetic gas. So, what happens is the pressure of in controlling gas or oxygen pushes this diaphragm downwards. The stem is pushed downwards, leading to coiling of this spring and opening of this seal, leading to flow of gas from this to outlet. So, if in case the pressure of oxygen decreases, the diaphragm will move upwards, the stem will move upwards, the spring will move upwards, leading to blockage of this area, and there will be decrease in the flow of anesthetic gases or other gases. So, After this, we will be discussing gas selector switch. Gas selector switch may be present or may not be present. It prevents use of air and nitrous oxide together. So there is a switch. The direction of the switch decides which gas will be used along with oxygen. So in this diagram also we can press the button and a red light will be blinking on the gas selected. If we select nitrous oxide, there will be a light on the panel, or if we select air, there will be a light on the panel. So this is usually present in newer machines. Then we have second stage pressure regulator. The function of a pressure regulator is to decrease or further decrease the pressure. So second stage pressure regulator further decreases the pressure to 26 psi of nitrous oxide and 14 psi of oxygen. And what is the benefit? It causes the flow from flow meters to remain more constant. So after discussing all this, we come to oxygen flush. Oxygen flush is a very important part of anesthesia machine and very important safety feature. This is a diagram of oxygen flush. It is also known as oxygen bypass, and it is also known as emergency oxygen bypass. It is used in emergency situations to provide oxygen to the patient. It can receive oxygen either from pipeline or cylinder depending upon the anesthesia manufacturer or the hospital protocols. Then it provides high flows. We have to remember that it provides flows of around 35 liters to 75 liters per minute, and the flow is unmetered. We cannot measure how much flow was generated while we used oxygen flush, and that unmetered flow is directly sent to the common gas outlet from where the patient can receive oxygen. The label is O2 plus, as you have seen in this diagram. The label is O2 plus and it works irrespective of master switch. We have already discussed this. It works irrespective of master switch. Either the master switch is on or off, it doesn't matter, oxygen flush will work. So disadvantage is that it alters other gases flows. It can alter the flow of flow meter, it can alter the flow of vaporizer, it can cause back pressure, it can generate positive pressure inside the circuit, and it can dilute the anesthetic gases. So if it is accidental, there is accidental activation or there is an internal leakage which is not being detected from the oxygen flush, it will lead to barotrauma because of high volumes delivered to the patient. 35 to 75 liters per minute is a huge volume. It will cause barotrauma to the patient and it will cause dilution of the anesthetic gases, causing awareness to the patient. So patient can experience awareness. So in order to prevent these hazards, you can see in this image the position of oxygen flush is along the lining. There is no protuberance of oxygen flush. So in absence of protuberance, it prevents accidental activation. And one of the other safety feature is that when you press it, then only it will deliver it. It is not like switch on and it will be on. Until you give the pressure from your thumb, it will be on. So this is a safety feature to avoid accidental on of the oxygen flush. Then we will be discussing the flow adjustment control knobs. So per gas, we have one flow adjustment control knob. There can be two flow meters, two tubes of flow meters for a gas, but there will be only one flow adjustment control knob. So this is a schematic diagram with flow control knob and flow meter. So this is the control knob. There are safety features of this as well. We'll be discussing. This is the needle. Then we have an inlet for gas. This is the bobbin stop. Bobbin stop is at the start of the tube and end of the tube to prevent sticking of the bobbin. We will be discussing flow meters in the next class. Then we have a tube, tapered tube. We have bobbin as an indicator of flow of gas, and then we have an outlet of gas. So flow adjustment control knobs can be mechanical and can be electronic. Electronics are usually seen in newer machine, and electronics are just representation of mechanical in the backstory. So mainly there in the machine manufacturing there is a mechanical, and electronic is just a representation of mechanical. So mechanical has many safety features. So there is a standard protocol that clockwise direction of knobs closes the gas, anti-clockwise opens the gas. This is a safety feature, uniform for all machines. Then there is a stop for off and maximum flow. The knob cannot be rotated infinitely. There is a stop so that there is regulated flow of gas, and it avoids damage and dislodgement of the valve seat. So oxygen flow control knob has safety features, as oxygen is a very important gas during anesthesia delivery. To keep the patient oxygen levels maintained, we need to have oxygen handy and prevent patient from getting hypoxic. So the knob has fluted profile. It has, suppose this is a knob, there is serrations. You can see in your OT that there are serrations on the knob of oxygen, and it is larger. The serrations are larger. They look different and feel different. So without turning towards the machine, even with your touch, you can understand that you are turning on oxygen only. So that is why it looks different and feels different. And the position of the flow control knob is shielded. There, suppose this is an anesthesia workstation, suppose just a schematic diagram. So flow control knobs will be higher. If we keep our drugs here and our airways here, so the knobs will be higher from this position. So shielded or barred, and they are high enough to prevent accidental opening of the flows, and we have to close them when not in use. And there are electronics as well. I will show you a diagram of electronic flow meter. So this is a diagram. As you can see, the total flow is decided here, and the oxygen percentage is decided here, and we can select the gas, and accordingly this is an electronic flow meter. After discussing flow meters, flow control knobs, then we have there is presence of an alternative oxygen control in some machines, which comes in intermediate pressure system, and it is separate from an auxiliary flow meter. It is also used in emergency situations. If the anesthesia display is not working, we have to just switch on this button, press this button and turn this knob on, and the flows will rise. So this is used in emergency situation, or there is total loss of electrical power and the machine is not working. So this will provide oxygen to the patient. So now, after discussing intermediate pressure system, we will be discussing safety features of intermediate pressure system as well. As we were discussing intermediate pressure system, we have discussed some of the safety features. We will be just revisiting them. So pipeline safety features are, there is non-interchangeable screw thread. You cannot use oxygen shredder probe in another air or nitrous oxide pipeline, and they have different diameters, so diameter index safety systems. Then the color of the pipes, hose pipes are color coded. You can check for yourself in OT. Oxygen pipeline has white color, air has white and black stripes, nitrous oxide is blue, and we have to also see that there will be a suction pipeline which is yellow. There are shredder probes and outlets as a safety feature which cannot be interchanged. There are shredder outlets and shredder probes. Unidirectional check valve prevent backflow of gases. Then after pipelines, we have oxygen pressure failure devices, which we have discussed earlier. If the oxygen pressure, in some books it is written 20 psig, in some books it is written 30 psig. So if the oxygen pressure falls below 30 psig, there will be a proportional decrease or shutting down of other gases. And then alarm system, in alarm system we have Ritchie's whistle. Ritchie's whistle is an audible alarm. It cuts off other gases. It starts within 5 seconds, and what we have to remember is that it cannot be muted, and it is a good thing only that it cannot be muted. So what is done is it decreases or cuts off other gases. As we have already discussed, oxygen pressure failure devices only detect pressure, not flow. So second safety device, other safety devices, second stage pressure regulator, which makes the flow more constant for the low pressure system. So pressure reduced is, oxygen is 14 psig, nitrous oxide is 26 psig. And the other feature we have to discuss is oxygen flush. As I have already told you about oxygen flush. Oxygen flush is a very important part of anesthesia machine, providing oxygen in dire emergencies. So oxygen flush has safety features, many safety features. It is labeled O2 plus. It works only when pressed. It works until pressed. It is not like it is not like once you press it and then it will continue delivering oxygen at unmetered flows. It is not like that. You have to just keep pressing it until you need it. It has recessed settings. It is not coming out of the surface, so that there is no accidental activation or accidental pressing of the button. It does not sticks. So we have discussed safety features of oxygen flush as well. So this was intermediate pressure system with its safety features. In the next class, we will be discussing low pressure system with its safety features. I hope you liked the material. If you have any doubts or if you would have any suggestions, please write in comments. Thank you.